Okay, so this is the 6.3 notes, tests for parallelograms. All right, so in the 6.2 notes, we learned the properties that if the quadrilateral is a parallelogram, then all of these properties apply. Each pair of opposite sides are parallel, each pair of opposite sides are congruent, each pair of opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So remember back from chapter 2, right? This if then is a conditional statement, right? If this, then this. Now we're going to learn the converse, okay? There are many ways to establish that a quadrilateral is a parallelogram. So in order for us to prove that a quadrilateral is a parallelogram, we're going to take the converse. Meaning we are going to switch this order. If these properties apply, then the figure is a parallelogram. Okay, so we're going to kind of go through these with this figure right here. If both pairs of opposite sides are parallel, meaning that side AB is parallel to DC and side AD is parallel to side BC. So if that is true, if both pairs of opposite sides are congruent, so if AB is congruent to DC, and if AD is congruent to BC, so if that is true, or if that is true, right? If all of these properties that we learn in 6.2 are true, then the figure is a parallelogram. So we're taking that converse. Okay, if I took both pairs of opposite angles are congruent, if angle ABC, which is up here, is congruent to angle ADC, those are opposite, and then angle DAB congruent to angle BCD or DCB, whichever, right? As long as that opposite angle, that is the vertex, the middle letter, okay? If diagonals bisect, so if AE right here is congruent to EC, and DE right here would have to be congruent to EB. Okay, if we can prove any of these properties, then the figure is a parallelogram. There is one new property, and I think I discussed it in the 6.2 video. Okay, I did mention this. But this is if I'm proving a parallelogram, right? If I don't know all of it, if it only says this figure is a quadrilateral and I'm trying to prove that it is a parallelogram, I can use this property right here, kind of like a shortcut. If there is just one pair of opposite sides, congruent and parallel, if they are both congruent and parallel, then it's a parallelogram. I do not have to prove the other pair of opposite sides. So if I can prove that AB is both parallel to DC and also congruent to DC, then the figure is a parallelogram. Or if I can prove that AD is parallel, there should be two lines, to BC, and AD is also congruent to BC, then the figure is a parallelogram. So this is an extra kind of property to prove a figure is a parallelogram. It does not mean that it's one of the properties if it is a parallelogram already, even though it would be true, but I can use this kind of shortcut to prove a quadrilateral is a parallelogram. Okay, so we're going to kind of use what we're given right here in this section to determine, does it meet any of these conditions, right? I can just have one to prove that it's a parallelogram. So if I'm looking at figure 1 right here, this should be regarding the diagonals, right? Because these tick marks are on the insides on the diagonals. So right here, let's say this diagonal right here, it is saying that this piece is congruent to this piece. And on this diagonal, it's saying that this half is congruent to this half. So my diagonals are both cut in half, meaning that they are being bisected. That is one of my properties, right? If this, then this. So this would be yes. The property that proves it would be that the diagonals bisect each other. So you're going to tell me yes or no, is it a parallelogram? If yes, by which property? Diagonals bisect each other. Okay, and you're only going off what you're given. You do not need to mark anything else congruent, nothing extra parallel. Okay, only go by what you're given. On number 2, all they have told me with those marks is that this side is parallel to this side. Remember, the arrows mean parallel. All I have so far is that one pair of opposite sides is parallel. In order for it to be a parallelogram, I need both pairs of opposite sides to be parallel, or one pair would have to be both parallel and congruent. So I don't have enough information to prove that this is a parallelogram. So this would be no, because only one side, or one pair, I'm sorry, only one pair of opposite sides are parallel. I either need both pairs of opposite sides to be parallel, or that one pair of opposite sides has to be both parallel and congruent. Number 3, they give me some angle measures, so I would be looking at this property right here. Both pairs of opposite angles are congruent. If I look at 118, opposite of that is also 118, so those are congruent, so I can mark those. 62, opposite of that is also 62. So these opposite angles are also congruent. So yes, both pairs of opposite angles are congruent. Okay, as long as you can satisfy one of these, then the figure is a parallelogram. Number 4, it looks like I have one pair of opposite sides parallel and the other pair of opposite sides congruent. This is a great question because you would think that it would go with this property. One pair of opposite sides is congruent and parallel. But this is no, because in order for it to meet this condition, right, this property, it has to be the same pair of opposite sides, which would be number 5. This would satisfy this condition right here. Only one pair of opposite sides are both parallel and congruent. Okay, this is what that means. Not number 2, not number 4. Okay, so I'm gonna just put C number 5. Okay, and then number 6, it looks like I have opposite angles, both have one loop, meaning they are congruent, and another pair of opposite angles both have 2 loops. So yes, both pairs of opposite angles are congruent. Okay, so we are testing if these figures are parallelogram based on these conditions. Okay, so let's go ahead and flip to page 15 in your packet. Now, a lot of the problems are going to be very similar to just, solving, right? If I told you that this quadrilateral is a parallelogram, well, then we know all those properties to be true. So a lot of it is very similar to as how you solve it. It's just the wording of the question. So it's asking us to find x and y so that each figure is a parallelogram. They want us to prove that this is a parallelogram. So if I have angle measures, remember angle measures are on the inside of the figure, that means I'm looking to prove that both pairs of opposite angles are congruent. That's the property that I'm trying to prove. If I want to prove that, I would need to set them equal to each other because they should be congruent if it's a parallelogram. So let's start with x. This angle, 7x, should be congruent to this angle, 56. In order for them to be congruent, I have to set them equal to each other meaning that x should equal 8 in order for this to work. X cannot equal anything else or it will not be a parallelogram. Same with these two angles. These two angles should be the same, so I would set them congruent to each other. 4y plus 4 is equal to 5y minus 26. Get my variable on one side. That cancels. 4 is equal to y minus 26. Add over 26, so y is equal to 30. So the only way for this figure to be a parallelogram is if x is equal to 8 and y is equal to 30. That's what it's asking you. So yes, you're solving the exact same way, but what it's saying is find these values so that it's a parallelogram. It can only work with this x value and this y value. So same concept for number 8. This time I have side measures, right? Meaning I should be looking at the property that opposite sides are congruent. So this 4y minus 9 should be congruent to 2y plus 5. So I would set those two sides equal to each other to solve for the one and only y value that would make this a parallelogram. So if I move my variable to one side, 2y minus 9 is equal to 5. Add over 9, 2y is equal to 14. Y has to be equal to 7 in order for those two pairs or those two sides to be congruent. Same thing over here. Set these two opposite sides equal. 3x plus 4 is equal to 5x minus 2. Get your variable on one side, so minus 3x. 4 is equal to 2x minus 2, add over 2, 6 is equal to 2x, divide by 2, x should equal 3. So again, these are the only two x and y values that would prove this figure to be a parallelogram. Okay, now we're going to do some coordinate geometry, looking at a coordinate plane on a graph. Okay, and we're going to really look at some formulas that we know from the beginning of the year that are all on your formula chart, and we're going to match them with some properties about a parallelogram. Okay, so this is important because you will see questions like this on a quiz or a test. It says, using the coordinate graphs below, determine whether the following figures with the given vertices are parallelograms. So again, we're figuring out, does this form a parallelogram? Use the slope formula. So we have to kind of think here. Why would I be using the slope formula? On a graph, the slope of lines can only tell me if they are parallel or perpendicular or neither. Okay, so if I look at my table, there is a property where if I can prove that both pairs of opposite sides are parallel, then the figure is a parallelogram. So if I can only find out if lines are parallel, perpendicular, neither using slopes, then that means I need to prove, are my sides parallel? So if I just start with side AD and I find the slope, AD should be parallel to the opposite side, BC. Okay, rise over run. From D to A, I go up 1, 2, 3, right 1, 2. So that slope is 3 over 2. Over here, from C to B, rise over run, up 1, 2, 3, right 1, 2. So these two sides are parallel. Now I have to test the other pair of opposite sides, AB, DC. From A to B, rise over run, I go down 1, to the right 1, 2, 3, 4, 5, so negative 1 over 5. From D to C, I go down 1, right 1, 2, 3, 4, 5, so negative 1 over 5. So these also have the same slopes, which means that those two sides are parallel. So yes, this is a parallelogram because both pairs of opposite sides are parallel. So it's asking us, what property would we prove using this slope formula? Both pairs of opposite sides are parallel.